Okay. Good afternoon, all my dear students. Today we will start. So before start the today's lecture, I will discuss with the syllabus of. So now, dear all students, I have to send a syllabus copy in the DSY 21 group. Please, all of you go through it. Okay. So this is the syllabus copy. That is uh, microprocessor, and your subject code is 215 CS 215. So please respond to me. Am I audible and my screen is visible to you?
Yes, sir.
Sir.
Okay. Okay. Thank you. How many students? Okay. All students are present. Only one more students. Who is left out? Okay, anyhow, yes, fine. So, dear students, as per the syllabus copy, already we started first unit. We have completed first unit. Very simple, just for the 4 hours lecture topic. Only two are the main things: introduction of microprocessor. So in that, features and pin diagrams we studied very well. Features of the 8085 and all the pin diagrams of 8085 we studied. And also we have to study microprocessor architecture. That microprocessor architectures also we have to study it at the last lecture. So all of you, how was the notes? Is it appropriate? Are you expecting anything more than that?
No, sir, they are very easy to understand.
What about notes? No notes. Is it up to the mark? All of you understood about the notes? Whatever I provided?
Yes, sir. Yes, sir.
Okay. Okay. Thank you. So first units I have to given that printed, but second unit onwards, again more than easy. I have to mail to you. I only written by my hand, and that notes I will provide to you. That is too much easy again compared to this one. So first unit is the very smallest unit. So that's what uh, even it is all of you studied. That is very simple things are there in the first unit. So from the first unit, these topics I have to cover. Okay. So now you have a time uh, on this first unit topic. Any of the topic you have any doubts or any not understanding, or are you facing any problems, please let me discuss if you have any doubts. Okay, otherwise what I will do, I will move to the second unit, 8086. If you don't have any doubts, then I will move to second units. Okay. So in the second units, we have to study the entire introduction about 8086. In the first unit, we have studied 8085, and in the second units, we have to study 8086 architecture, like of your 8085 microprocessor architecture, and internal operation of 8086 architecture, and machine level language instructions. So these machine level language instructions are nothing but addressing modes and instruction execution timing. So three topics we have to study in the 8086, that is architecture of 8086 and internal operations of that. And we have to study address modes, that is machine level language instructions and instruction execution timing. Again, very simple in the second unit. Today, I have to start your second unit as per the syllabus. Okay. So for this, I have to make one of the very user friendly, student friendly, and easy language. I have to prepare one notes. So that notes also, okay, this is the notes. So these notes also I will provide to you. Okay, now only better. Okay. Uh, okay. Again, bit things I want to add. So today I have to complete these notes and I will send you within today. Okay, just we have to go through the class. So at the first, as per the syllabus, uh, where is that? 8086 architecture, internal operations. Before that, bit introductions I will give you. I will mention in my notes. That is here, features of 8086. That is the features of 8086. In that, so previously in the unit number 1, we have studied some points. Just 5 minute I will give you refresh for that. What are the things we studied? We studied definitions of microprocessors and components of microprocessor 8085, and we studied system bus, we studied features, we studied architecture. So here in one or two lines, again I have to mention here, that is buses. First point is buses. So in this, there are mainly three types as we already studied. Address bus, first one, and the second one is data bus, and the next one is control bus. What address bus will do? It will just carries the data of 20 lines, 20 bit address lines. It is carrying the data or the information from one place to any another required location. Okay. And data bus and the address bus, what it will do? It will find the particular location where to send the data, where to send the information. Data bus is nothing but the data or the information which is carried into a particular bus. Okay. After that, control bus, the main functioning of data bus and the main working functioning of address bus. These two buses controlled by the control bus. That the control bus carries the signal responsible for performing various operations such as the ready state, writing, reading, etc. like that. Okay. So this is regarding about buses. It is the one of the main features of 8086. And next main features of 8086 is, that is 8086 supports pipelining. Pipelining means what? One by one, or one on another, the instruction is going to be executed continuously. Instructions are going to be executed continuously. That one we have to say pipelining. So that pipelining characters is supported by 8086. So we have to say 8086 is having a one of the main features, that is to supporting pipelining in the microprocessor. Okay. Next, the third main feature is it has two operating modes. So the 8085 is not having two operating modes, but the 8086 has two operating modes, that is minimum mode and maximum mode. So in the minimum mode and maximum mode, entire this minimum mode and maximum mode is a one of the init, that is init number 4. So in the init number 4, in detail, we have to explain what is minimum mode and what is maximum mode, how it works in the microprocessor. Okay. So and one more, uh, fourth main features of 8086 has, it has a 256 interrupts. In 8085, only 5 hardware interrupts and 9 software interrupts are there. But in 8086, totally 256 interrupts are there. That is interrupt service routine, we have to say. ISR, it means interrupt service routine addresses for the interrupts are stored in interrupt factor table. Okay. And the fifth main features of 8086, it provides a memory bank. Memory bank means it having a lot of memory compared to 8085. Lot of memory, it means the entire memory is 1 MB, which is divided into two banks, that is 512 KB. So 512 MB each, that it becomes a 1 MB. 512 KB each, it becomes a 1 MB in the order to transfer bits in one cycle. And the banks are called lower bank for the even number and for higher bank for the odd numbers in the memory locations. Okay. So that is the fifth main features. And in the sixth main features, thus it is having a sub segmentations we have to use. So for totally 4 segmentation we are going to use. That 4 segments are nothing but code segment, data segment, stack segment, and extra segments. So the entire memory in the 8086 we have to categorize, we have to divide it into 4 main groups, that is code segment, data segment, stack segment, and extra segment. Segment is, means what? Actually, The segment means it is a dividing portion of the main memory. So if one main memory is there, as per our requirement, we are going to divide the memory. So that one we have to say segmentation. Okay. And the seventh main features of 8086, that is, it has a 16-bit data bus. Please, all of you remember 8085 is having a 8-bit data bus, but the 8086 is having a 16-bit data bus, and it can access 2 raised to 16 input and output ports. That is, 2 raised to 16 is becomes a 64K, 64,000 input and output ports. So these main 7 features are very important for the features of 8086 buses. Okay. So again, after that, we come to know the features as per the syllabus. We will go for architecture of 8086. So here I will show you the one diagram, that is architecture of 8086. So this 8086 is totally different, not totally, maximum different from the 8085. In the 8085 is only used for 8-bit data lines and no pipelining, no that memory bank, and no segmentation. But here in the 8086, we have to use the segmentation, and that entire architecture of 8086 we are get categorized or divided into two main parts: bus interface unit. The first one we have to say bus interface unit, and the second portion, this is the dotted lines. This dotted lines is divides it into two main category parts. One is this upper part is bus interface unit, BIU, and the second one is execution unit, EU. EU means what? It's the execution unit. And here we have to use this bus interface unit. We are using segmentation of memory, that is nothing but extra segment, ES, code segment, CS, stack segment, SS, and data segment, DS. So these are the memory. It is entire one memory. This memory we are get divided into different sub parts of memory. That is totally 4 main memories: ES, extra segment; CS, code segment; SS, stack segment; and DS, data segment. And the last one we are again adding 4-bit lines of instruction pointer. This is the instruction pointer along with the memory. So this each memory is having a 4 bits, and this instruction pointer is also a 4 bits. So totally this 4, 16 plus again 4, totally 20 address lines are there in the memory locations of 8086. Okay. And here somewhere in that we are using instruction stream for 6-byte prefetching queue. So there are 6 bytes: byte number 1, byte number 2, byte number 3, byte number 4, and byte number 5, 6. Totally 6 instruction streams for the prefetching queue purpose also we are using. So this is for the upper half part of the 8086 architecture explanation. Okay. And this entire memory, whatever the logic, arithmetic, and logical operations is happened. Arithmetic operations means addition, subtraction, multiplication, division, and also the logical operations means AND, OR, XOR, XNOR, NOT, NAND gates operations is done. That's what I have to say it here. Summation. This is the symbol of summation here. Okay. So this is entire explanation of architecture of 8085 upper portion. That one we called it as bus interface unit. So in lower half of the part, that is for the execution purpose. That's what we have to say execution in it. So in the execution units, we are using some storage registers, storage purpose registers. Those registers we call it as AHKL, BHBL, CHCL, DHDL. So in 8085 also we are used A, B, C, D, E, H. We are using registers, right? So those are 8-bit registers. So because of 8086, it is a 16-bit register. We are going to use 8-bit A and 8-bit A. So here H means higher nibble and L means lower nibble. 8 plus 8 becomes a 16. That's what we have to use it in the pair of AH and AL, BH and BL, CH and CL, DH and DL. Along with that, these memory location, stack pointer, base pointer, source index, and destination index. Stack pointer is very important for getting to a particular location, as well as base pointer, and the source index, destination index. Source index means where the data is present, and destination index means to where we have to transfer the data from the destination. Okay, so this is the storage purpose we have to use it. A, B, C, D with a H higher nibble, A, B, C, D with a L lower nibble. At lower nibble 8 bits and higher nibble 8 bits. Totally it becomes a 16, 16 bit. 8 plus 8, 16 bit. That's what we have to say. 8086 is a 16 bit. And along with that, some manipulation of operations, data, information. That purpose we are using stack pointer, base pointer, source index, and destination index. Along with that, again we have to use it arithmetical operations, arithmetic and logical operations, like in our bus interface units. So here we have to do the operands. Operands means what? All are addition, subtraction, multiplication, division. And for the logic operations, we have to use AND gate, OR gate, NOT gate, NAND gate, XOR gate, XNOR gate. Like that, we have to use it. So this is, and this entire system is going to be controlled by the control system. There is the one control system that is controlled it. Okay. So this is the explanation of entire 8086 architecture. So here in detailed explanations, I have to explain it in the notes. That is first half of the port, bus interface unit, BIU, as in the diagram. Okay. And the second portion is GU, execution unit. So first in the bus interface units, all the explanations clearly I have to given you. So in that bus interface unit, it is used for to interface with 8086 with the other devices, and the input and output read write operations, memory manipulations will be done by this bus interface unit. So in that there are mainly four functions are there. That is the first one to generate 20-bit physical address for the memory access, and the second one that is to fetch instructions from the memory, and the third one that transfer the data to and from the memory to the input and output devices. And also it can support the pipelining using the 6-byte instruction queue. This is the 6-byte instruction queue. For this, it is supporting pipelining. Okay. And next I'll come to the points of segment register. These are the segment register ES, SS, DS, ES. So here the CS is means what? Code segment register. It is used for the storage purpose in the bus interface unit. It can to hold the address of another, which is the code segment, and it can programs are stored in this code segment. All the programs are stored for this code segment, and also it is multiplied by the 10h to give the 20-bit physical address with the data bus lines. That is for the code register. And the next one is the DS register. It is also used to hold the base address. DS is the used to hold the base address of the data segment, and it is multiplied with the 10h value to give the 20-bit of physical addresses. So physical addresses calculations, next topic it will come. I will explain in that time. Just the DS also used for to generate the physical addresses. And the stack segment, this stack segment holds the base segment address for the stack segmenting. So in that mainly the push operations and the pop operations for adding the data and deleting the data, we have to use SS register, stack segment register. And the next one, extra segment register. So in this extra segment register, it is holds the base address of extra segments. If the memory location is not enough, we are not getting sufficient memory, that time we are using extra segment, extra memory in the 8086. That opportunity is there. That's what the 8086 is too much popular over than 8085. Okay, so this is the bus interface in it. So in this next part, that is instruction pointer again, fifth one. So what the instruction pointer will do, that is it is also a 16-bit register, and it holds the offset address of 4-bit plus 16-bit. Finally it becomes a 16-bit plus 4-bit is equal to 20 bits for the data lines of to transfer the information. And if the it is increased after every instruction byte is fetched, when that branch is occurs if to modify, and the new value is going to be generated by the instruction pointer. What instruction pointer will do? It can hold the address of another for to recognizing the particular data or information. Okay, so this is about all the things of bus interface in it. And in also a bus interface in it, we have to use the physical address generation circuit, and that physical address generates the 20 bits of physical addresses using a segment and offset addresses. And also this is very much useful for 16 plus 4. 16 is segmentation and 4 is for uh, instruction pointer. Totally the physical address is become a 20 bits is used. Okay, so the physical address is equal to segment address into 10 hexadecimal value plus offset address. This one formula, please, you have to remember. Physical address is equal to segment address. Though so the segment address, it may be a code segment, stack segment, data segment, extra segment with the multiplication of 10h value plus offset address. This offset address is given in the question. So finally you have to calculate total physical address. Okay, and next one is a 6-byte prefix queue at the bus interface in it. So in that, it's a 6-byte first in first out queue, that is RAM used to implement the pipelining, and the bus interface unit fetches the next 6 instruction bytes every time from the code segment and to store it in the queues. Okay, so the queues are refilled with uh, two types of main memory, that is the 8086 has 16-bit data bus and 4-bit instruction pointer to transfer the data. So in that fetching the next instruction, the execution is going to be speed up for the instructions. That is called pipelining. Okay, so the pipelining which can increases the efficiency of entire bus interface in it. That is to increase this efficiency of bus interface in it, and also it can prefetch the instructions for longer useful, which can use to execution of the program for the instructions, and the next 6 byte from new location are fetched and stored it in the pipelining continuous. Okay, so that pipelining one small structure I have to show you in the near notes, that is non-pipeline processor Non-pipe. The example for non-pipeline processor is 8085, and 8086 is a pipeline processor. So this is a non-pipeline. The only single door is there. Every time one by one it is going to be fetching. But here it is in the parallelly overlapping fetching and execution. That is only possible in the pipeline processor. That pipeline processor is going to be executed with the parallel F1, E1. This extra segments with F1, F2, F3, F4, F5, F6. Okay, so that one we have to say pipelining. That's what the 8086 is the more popular because of it supports the pipelining features. Okay, so this is all about bus interface unit. This is all about bus interface unit, upper portion of architecture 8086. Next, I will move to the execution unit. That these blocks I am going to explain all the registers, arithmetic and logic, and operands. Okay. So here next we will move to execution unit. So in that execution unit, it fetches the instruction from the queue in the bus interface unit and to decodes and execute them. So whatever the instructions is comes from the bus interface units in a queue, that is going to be decodes and execute the instructions. And also it performs the arithmetic, logic, and internal data transfer operations. What are arithmetic and logic operations means? Addition, subtraction, multiplication, division for arithmetic, and all, nor not, x nor, x and. These are the logical gates. Okay, these are the operations is going to be done in the execution unit, and it sends the required signal to the bus interface unit to access the external model. To access the external models, and also it can operate with the respect to t states. T state means what? As per the clock cycles, clock generator, it will work. So the main components of the EUR as follows. So in the execution unit, there is a general purpose registers. Those are nothing but AX, BX, CX, DX. So here I have to mention X. X means what? Either it may be a H or L, AH or AL, BH or BL, CH or CL, DH or DL. So generally we have to use it AX, BX, CX, and DX. AH, AL, 8 plus 8 is equal to 16 AX. That's why in general we have to use the AX register. Okay. So these are the available for programmer for storing the values during the program. And each of these instructions is divided into two main bits, that is registers such as AH, AL, as I said, BH, BL, CH, CL, DH, DL, like that. So every register also have a specific functions. Those are AX register. It means that what? It holds the operands and results during the multiplication and division operations. And also all the input and output data transfers using in and out instructions are uh, registers with the AL or H, or normally we have to call as AX. AL or H is called as AX. So and it is the main functions of accumulator during the string operations. Same here in the BX register, BH or BL, it can hold the memory address in the direct addressing modes. And the CX register also is 16 bits. All are 16 bits only. Same way, it also holds and to count the instructions like loop, rotate, shift, and string operations. And DX register, that is 16-bit register. It is also to hold 32-bit of value AX. AX means what? AX plus AX is 32-bit value during the multiplication, after the multiplication and division. Okay. So it is used to hold the address of input and output ports in the indirect addressing modes. That is very much essential for DX register. Okay. So and the special purpose registers, we have to use it. So in the architecture, here clearly I have to mention these are the general purpose registers and these four are the special purpose registers. General purpose registers are AX, BX, CX, and DX. Special purpose registers are stack pointer, base pointer, source index, and destination index. Now I will move to special purpose register. These special purpose registers are stack pointer 16 bits, base pointer 16 bits, source index 16 bits, destination index 16 bits. Stack pointers are used to address the top of the stack. As the top of the stack address, we are using the stack pointer. And also the base pointer, we have to use it for offset address. Base pointer, we have to use it for offset address. Stack pointer, we have to use it for top of the stack address. And the next one, source index, it is the source point location. It is normally used to hold the offset address for the data segment and other segment using the segment overriding. That is source index, beginning point. And next one is the destination index, where we have to send the data, all the information at that point. Normally used to hold the offset address for the extra segment because that is the point of destination. So this is the special purpose register, and the previous one general purpose register. Next I move to the ALU. That ALU is present in the architecture, this portion. So this is the ALU portion. Okay, this is the ALU portion. So the arithmetic and logical units. What is we say? Arithmetic and logical units. It has also a 16-bit capacity. It performs 8-bit and 16-bit arithmetic and logical operations. Okay. So next one is the operand register. In the operand register, it is a 16-bit register used by the control register to hold the operand temporarily, and it is not available for the programmer. Okay. And also the instruction register and the instruction decoder at the last point in the architecture. So in the execution unit fetches an operation code or from the queue into a instruction register, and the instruction decoder decodes it and sends the information to the control circuits for the executions. So along with that, execution unit and bus interface unit in the architecture of 8086, we need some very important flags. Flags means what? Either in the high state or in the low state, whichever is going to be enabled and it is going to be to resolve it. That is flag registers. So in the flag register, there are totally 9 types are there. 9 types of flags. So in the 8085, we are using only 5 types of flags, as you already know in the first unit. But in the second unit, 8086, we have to use 9 flags. All 9 flags are, I have to mention here. That is carry flag, parity flag, zero flag, auxiliary carry flag, sign flag, trap flag, interrupt flag, direction flag, and overflow flag. So as we said, the 8086 is having a 16-bit. So from the here to here, it is totally a 16, 8 plus 8, 16 bits are there. So first one, it is used for carry flag. If the carry is high, then we have to use the carry flag is enable. Otherwise, no carry, then no enable for the carry flag during the operations of either it may be arithmetic or it may be a logical. Okay. And the next one is PF. CF means carry flag. PF means parity flag. So if it is high, the parity flag, if it is high, then that should be 1 for the even numbers. If it is parity is no parity, then that should be 0 for odd numbers. 0 for odd numbers means no parity. 0 for 1 means it is a parity flag. Same way we have to use it. AF means auxiliary carry flag. So in that auxiliary carry flag, if 1 means carry from lower nibble while going addition or subtraction. Carry from the lower nibble, then it becomes a 1. That time you have to say carry flag is enabled. Otherwise, there is no carry me from the lower nibble, then no carry. It means that the auxiliary carry flag is not enabled, isn't it? So next one is uh, ZF. It means zero flag. So this zero flag is nothing but it results to whenever it is high, otherwise it is no results means no enable. If it is okay, so that is zero flag. Next one is SF. It means sign flag. For the sign is going to be indicated as the MSB, most significant bit. If that is sign is negative, then we have to indicate it by 1. If it is 0, then we have to say that the positive number. So that is a sign flag. Next one is TF, trap flag. The trap flag means what? It is going to perform a single stepping or no stepping. If it is single stepping, the trap flag is going to be high. That's what we have to mention one. If no single stepping or no stepping, we have to use the 0 for the trap flag. So the next one is IF, which we say it is an interrupt flag. So entire one interrupt chapter is there at the unit number 5. Again, we are going to study all kinds of interrupts, but only here you have to just understand that in the interrupt means what? There is some abnormal conditions going during the execution of program. During the execution of program, if we have to use some abnormal conditions or some difficulties, that time that interrupt flag is going to be works. If any problems are occurred, automatically interrupt flag is going to be enabled. It means that at the high state, one state. If it is no any interrupts, that time it is become a 0, means disable the interrupting. So next one is DF. DF means what? Direction flag. So direction flag means auto increment or auto decrement. For the auto increment at the enable of direction flag means 1 high, and it becomes the decrement at the level of low level, that is 0 value, that direction flag is not enabled. So next one, that is OF, overflow flag. The overflow flag means what? If the data is filled in the stack, again we have to enter the data or the information to the same stack. That time the overflow is occurs due to the excess of data or excess of information. So that is indicated by overflow flag. So in this, if the 1 indicates the overflow is occur, and if 0 indicates there is no overflow, means that stack pointer is not filled by the data. Okay, isn't it? So this is all about 9 main flags, very important for your exam point of view. Again, these flags many times they have to ask for your practical overall examination. So please take care of this all 9 flags. Again, I have to repeat what are all 9 flags. Carry flag, parity flag, auxiliary carry flag, zero flag, sign flag, trap flag, interrupt flag, direction flag, and overflow flag. Very important. All these explanations you have to do. In the diagrammatically, I given it here, but you have to write in a statements if the exams are in offline. But anyhow, nowadays we have a online examinations MCQ. No that much difficulties for these explanations. Okay, so this is all about uh, architecture. This is all about architecture of 8086. Okay, so in the architecture of 8086, very simple. What are the things we have to study? In the architecture, mainly there are two parts, upper parts and lower parts. So upper parts we have to call it as bus interface in it, and the lower parts we have to call it as execution unit. Okay, so in the upper part we have to study some segmentation, that is extra segmentation, stack segmentation, code segmentation, uh, and instruction pointer. Okay, so these are we have to study it. Along with that, fetches of instruction queues we have to study. And in the next lower portion of the architecture, that is execution in it. In that we have to study general purpose registers, special purpose registers, operations, operands, ALU, decoders. So this entire things what I have to explain now. This is all about 8086 architecture. Okay. So now I will move upon internal operations. So dear students, what I will do now, please respond me. Am I audible all of you?
Yes, sir.
Yes, sir.
Okay, okay. So this instruction 8086 architecture, entire this init notes I'll share with you now. Uh, okay. All of you come to DSY 21 group. In that I will share this notes, second init notes. DSY. Okay, here. So here I have to add it. My PC. Okay. I think all you got these notes.
Yes, sir.
Okay. See, just for 15 minutes. Now it is 3:45. Just for 15 minutes, you go through these notes. Whatever I covered today, today's topic, features of 8086 and architecture of 8086. Just you go through it for 10 to 15 minutes. After that, again, I will start with next topic. So again, if you have any doubts, I have to clarify to you. If no doubts, again, I will continue with next topic, that is internal operation. Okay, just go through these notes for 15 minutes, scan it well, raise the any questions and ask me. I will take your attendance. Please go through these notes for 15 minutes.
मम्मीचा मोबाईल कुठे आहे एकच काढी रेंज आहे मला
So, any doubts regarding that?
No, sir.
Okay, fine. So please again, I'll give you time for the study purpose. So next, I will start with uh, as per the syllabus copy. Second point, that is internal operations of 8086 microprocessor. So up to now, what we studied, that is architecture of 8086. Architecture means what? Just what are the components of 8086? The components of 8086 is nothing but special register, general purpose register, and the segmentation, four different types of segmentation, and that coder, decoder, ALU, those things. So those are just a components of 8086 what we studied in the architecture. Okay. So now we will move to internal operations of all these components. Now we will move to internal operations of all these components or functionality, or we have to say working. That is nothing but internal operations of 8086. For that, come to my point, notes, internal operations of 8086. Okay. So in this internal operations, at firstly, I have to make four main points that is consist of the computer. So in that, at first, we have to fetch the data to the next instruction from the address indicated by the program counter. What purpose we have to use the program counter? That is for to fetching the next instruction. To fetching the next instructions from a address indicated by the program counter. And that one is going to be putting into the register and decoding it with the program counter is incremented to point. That is going to be for the next instruction again. And in the third point, once you have to fetching the instructions, and after that again you have to putting into the register for the decoding. After that we are get carried to the executing the instruction. So the third point is it is for the executing the instruction, and it is to branch is to be taken resetting the program counter to the branch address. So some different types of branch addresses that program counter is takes into from the execution instructions. That is the execution instruction, third point. And in the fourth point, you have to repeating until to get the complete execution. So again you have to repeat the steps 1, 2 and 3 up to getting complete execution. That is the main operations while you have to do. So doing this we have to use code segment, stack segment, extra segment and data segment. 4 segments whatever we are used in the architecture. And also all these segmentation of the memory is manipulated by general purpose register, special purpose register. The special purpose registers are what? Stack pointer, base pointer, source index, destination index, and the general purpose registers are nothing but AX means AH and AL, BX, CX, DX. Okay, like that. 16-bit general purpose registers we have to use it for the operation of 8086 internally. So here in the 8086 that can addresses the word which begins with either address, odd address or an even address based on the pipelining. And if it is an odd address, the 2 memory references are required. One memory access for low order byte and the other memory for higher order byte. That is low is L and higher is for H. And the times is going to be saved during the operations of different by using different this general purpose registers and special purpose registers. We have to save the time if the words are stored at given addresses. Okay, and enough 8086 instructions maybe we have to use that is based on the number of byte of instructions. So that is totally fills with 1 byte instruction, 2 byte instruction and 3 byte instructions for odd and even instruction. Okay, so for an even the address, so this is the just memory sketch I have to done with the first fetch, second fetch, third fetch. First fetch we have to say at the first instruction, second fetch we have to say at the second instruction, at the third instruction, like that. So totally that entering the instructions in the byte level. So this one we have to say that the instruction queue of an even address. So the first instruction has to an even address. Same way we have to use it for odd address also. That is first instruction has for odd address. That is first instruction, second instruction, third instructions for first fetch, second fetch and third fetch. So there are fourth fetch will be for the waiting into up to 6 fetching queues are there, right, in the 8086 architecture. So this much is enough for your internal operations of 8086. Only these 4 points, that is repeating the 1 to 3 steps up to execute the program instructions, and this is for the explanation of that. And these 2 memory diagrams just we have to draw for an on even address and an odd address. Okay, so only very short, that is internal operations. This is more than enough. So dear all students, I have to prepare some questions also. So that is at the beginning only I have to mention one question or two questions. That is, list and explain the features of 8086, or the explain four features of 8086. But I have to mention here seven features. And next one is explain different components of BIU. It means that bus interface unit and execution unit of 8086 in the architecture. Or some other way to ask the question, that is explain the architecture of 8086. After that, explain internal operation of 8086. So dear all students, just I have to given you three questions. First question, all of you please note down it. Dear students, first question, all of you please note down it. List and explain features of 8086. So I have to use one word pad better. Yeah. The first question is list and explain features of 8086. Sorry. The second question, briefly explain architecture of 8086. Second question. Third question, explain in detail internal operations of 8086. Third question, explain in detail internal operations of 8086. So these three questions, all of you, just you have to recall from my notes. Okay. So all of you just go through these three questions. Is it I covered or not? That one also you have to check. And is it there in the notes or not? That one also you have to check. So you have to go through these three questions. Okay. So I'll stop it here for the today's lecture. Please, all of you, you have to recall these three questions and you have to go and study in your home. Next lecture, I have to start with addressing modes. Okay. The next lecture, I have to start with addressing modes. So different addressing modes we have to study. That is general instruction format and addressing modes we will study in the next. So all 5 to 6 types of addressing modes we will study. Okay. So thank you, all my dear students. Thanks for your cooperation. Please go through these notes. Don't waste the time. Still, we have 20-minute time. All of you scan these notes and you have to prepare for these three questions, whatever I given. First question is based on features of 8086. Second question is based on architecture of 8086. And the third question is based on internal operations of 8086. Please, all of you go through it this 20 minutes. Okay. So thank you one and all. I'll stop it here. Only rule number 6 is absent. Who is rule number 6? Please you insist them to attend the lecture. Okay, I think you also got rule number 6. Yes, Abhishek. Okay, fine. All are present. 1, 2, 3, 4, 5, 6, 7, 8. Where is 8? 8 is absent. Yes, 8 is present. yes. Kulkarni. Uh, okay. Okay, all are present. Thank you for good strength to the today's lecture. Please, all of you maintain your 100% attendance, because if attendance is less, again it becomes a problem for you while applying the examinations of this semester. Okay. So please, it's my request to everyone, don't miss any single lecture. You be present for all the lecture for all subjects. Okay. So, okay, fine. Thank you. Now you can take a pause. And if any doubts, anything else, please let me know. Ask me anytime. So this my number. Okay, fine.
Okay, sir.
Okay.
Okay, thank you.
Okay, thank you all.